Hello everybody out there in YouTube land. This is Good Times for All or Zachary Zabala if you prefer. In this video, we'll be taking a deeper look into incoherent electrostatic acceleration, and we'll be calling this Part 2. I was happy to see so many grasp the concepts of the laws of electricity, but still see some having issues connecting all the pieces together. I am fully to blame, as I realized I did not touch on the subject of acceleration at all, and for this I apologize. It was an oversight we will try to remedy in this video. If you haven't seen the first video, I recommend watching it first, before continuing along here. The link is in the description below. First off, if you didn't notice from the first video, gravity does not affect anything down here on Earth and is only trying to explain the path of the luminaries above, i.e. the sun, moon, stars, and solar systems in the heliocentric model of our universe. I will once again show former physics professor of MIT for 4 decades, Dr. Walter Lewin, explain this in simple terms.
So what holds our world together? Well, on the nuclear scale, 10 to the minus 12 centimeters, very important are the nuclear forces. On an atomic scale, up to thousands of kilometers, it's really electric forces that hold our world together. But on a much larger scale, planets and stars and the galaxy, it is gravity that holds our world together. And now you may say, that's very inconsistent with what you just told us, because didn't you tell us that D cancels if you compare gravity with electricity?
Yes, but keep in mind that most objects in the universe have only a very small amount of charge per unit mass. The Earth and Mars have each a charge of about 400,000 coulombs. The gravitational force between them is therefore about 17 orders of magnitude larger than the electric force.
So even though our immediate surroundings are dominated by electric forces, including your own body for that matter, the behavior of the universe on a large scale is dictated by gravity.
As you heard, the professor stated quite plainly it is electricity that holds our world together.
On an atomic scale, up to thousands of kilometers, it's really electric forces that hold our world together.
See? Then he stated that not until referring to moons, planets, and stars does gravity take effect.
But on a much larger scale, planets and stars and the galaxy, it is gravity that holds our world together.
Any physicist worth their weight in salt knows that the electric forces here on Earth are 1,000,000,000,000,000,000,000,000,000. You know what? I lost count. Too many zeros. So we just say 10 to the 26th power. Anyone arguing about Newtonian or Einsteinian types of gravity are only speaking about the lights in the sky, or are over 150 years out of date, as this was well understood when Maxwell wrote his equations. This was the reason the ionosphere was created over 100 years ago, with no test to show it even possible to occur, how they claim. It is clear that many of us who were not educated much further than high school in physics were never taught this at all, and makes me wonder why they would tell anyone gravity holds them to the Earth. That was one part of the first video that some had overlooked and I thought was crucial to see. This is taught in the mainstream, high education curriculum, and is not something new we are sharing. Now that we have that out of the way, I would like to apologize once more for leaving out the acceleration part of the topic, as it is one of the most important parts to help us comprehend that there is a vector or downward bias here on Earth. Remember, a vector is an indicator showing what direction matter will go depending on the surrounding electrostatic field compared to its own electrostatic charge, and at what potential it will travel. Here on Earth, we have an electrostatic gradient in the atmosphere that rises in potential the further you get from the surface. The potential grows 100 volts every meter linearly as you rise from the plane, which indicates we are between two Gaussian surfaces. This you may remember from the first video, but what I left out was that only in one direction do things accelerate. Comprehending this is key to seeing the bias in direction. The only direction that matter accelerates naturally and with no outside force made by an animal, plant, or mineral is toward the Gaussian surface with less potential, better known as Earth. This acceleration is very weak at small distances, yet can be very destructive at large ones. The distance we are concentrating on is a vertical one, along the vector created by the Earth's electric field. Imagine dropping a bowling ball onto a couch from around 6 inches. It would make an indentation into the cushion, coming to rest in the center, and the couch would be in good working order after you lifted it off. Now we will drop the ball from around 10 feet up, and instead of the ball remaining on the cushion, it might now bounce off due to the potential it had when it made contact with the couch, causing a much larger reaction of the cushion and springs beneath. It gained this potential because it traveled longer along the vector line that caused it to accelerate. Last, we will drop it from an airplane. Not that I have tested it, but I doubt the couch would be much use as a furniture piece after the bowling ball came to rest, wherever that may be. Probably a few floors below the couch, I would bet. Now someone might claim a helium balloon does not succumb to these accelerations. But if you remember in the first video, this acceleration is very weak, and potential differences of other phenomena such as temperature, gas pressure, and buoyancy are much stronger. If one places a helium balloon in a vacuum chamber where it is more dense than the surrounding area, it most certainly shows it is affected by the downward bias. Outside the chamber, the balloon will rise, but not at an accelerated rate. The same with air bubbles underwater released by a diver. They do not accelerate up but are displaced by the water, which is more dense and therefore the matter in the area most affected by the downward bias. It doesn't keep accelerating up because the water around it only needs to travel the distance of the bubble before the potential is equalized again. The process is then again repeated with the water just above the bubble until it reaches the surface and there is no more water to displace it. Last off, I have heard some state the ideal gas laws disprove electrostatic acceleration on gases, and I must admit it makes me chuckle a bit. Here's a high school teacher explaining why they have to do this and that it is a make-believe place.
There are an uncountable number of molecules inside this balloon. It's my breath. But whatever the gases are inside of here, guys, this is absolutely chaotic. It defies study because it's so complicated. You get the idea? So guys, the question is, how do we fix this? And the answer is, we go to the land of make-believe. And guys, this is not stupid and this is not dumbed down. This is smart science. If you've got a system that's so complicated that you can't study it, what do? You simplify the system. And guys, that's what ideal gases are. Ideal gases are simplified gases that make our lives easier. Now guys, be clear. Do ideal gases really exist? No, but we treat them as if they exist. And what allows this to be the case? Don't write this down.
Hope this may have cleared up any misconceptions you may have had on the matter, or at least help further your comprehension of this phenomena. If you have made it this far and still haven't seen the first video, please click the link below and watch part 1 before asking any questions in the comments below. This is Good Times for All here signing out. As always, thanks for watching.